Our first task is going to be to look at a couple of examples where we take a set of real numbers and try to figure out whether there's a maximum or minimum, which are an upper bound that has to be in the set or a lower bound that has to be in the set, and whether or not we have a supremum, which is a least upper bound and may or may not be in the set, or an infimum, which is a greatest lower bound, which again may be in the set but doesn't have to be in the set. So let's take a look at a couple of examples. So let's take the set of numbers 2 minus 1 over n such that n is a natural number. So that's the counting numbers 1, 2, 3, 4, and so on. So when searching for things like a maximum and supremum, minimum and infimum, I think it's helpful to plot your set, if you can, on a number line. So let's take number line, say this is 0, 1, 2, and then let's plot the terms of this sequence on the number line. So the first term would be 2 minus 1 over 1. So that's 2 minus 1, or 1. That puts me there. The next term would be 2 minus a half. So that's 1 and a half. Puts me there. Then 2 minus 1/3, which is about 1.67. Puts me there. And then we can see what's happening. We're subtracting smaller and smaller numbers from 2. And so we are approaching 2, but we're not going to hit it. All right, so let's look at our collection of points and pull out the important members. First off, 1 is the smallest member of the set and also happens to be a lower bound for the set. So that's a minimum. As we will show, the fact that it's a minimum, in other words, a lower bound that's also in the set, automatically guarantees that it's the infimum. So if you have a member of the set that serves as a lower bound, it has to be the greatest lower bound. Now, what about a max or a supremum? Well, we can see that 2 is an upper bound for the set. And in fact, it's got to be the least upper bound because if I chose any point to the left of 2, eventually I'm going to get members of the set that go past it. So we're going to declare that 2 is the supremum of the set, right? It's an upper bound and the smallest upper bound that we could have, because if we tried a smaller one, we would get members of the set that go past it. But this is an example of a supremum that's actually not a maximum. This set doesn't have a maximum. Notice that 2 is not in the set, and any other member of the set would fail to be an upper bound because the next member would be larger. So this we would say has a max that does not exist. Okay, so our first example, minimum is 1. It's also the infimum. We have a supremum, least upper bound, that's 2. But that value is not in the set, and that's okay for a supremum. And then we made a note that the maximum doesn't exist in this case for this set. All right, so second example. So again, we're going to take a set that's based off of the natural numbers, so it forms a sequence in R, and we'll write down the first few members, plot them on a number line, and then make our claims about the max, min, supremum, and infimum. So let's make a little chart this time. We have n, if n is 1, Minus 1 to the n is a negative 1. Negative 1 plus 1 is 0, so I get a 0. If n is 2, minus 1 squared would be a 1. That would give me 2 on top, 2 on bottom, so that's a 1. If n is 3, odd exponent, taking negative 1 to that exponent gives me back negative 1, so another 0. And if n is 4, 2 over 4. And so we see a pattern where every odd term is 0, every even term is 2 over that denominator. So on the number line, this looks like, here's 0, and let's go out to 1. So the first term is 0. The second term is 1. Third term is 0 again. The fourth term was a half. Fifth term is 0. Sixth term is a third. And then we go 0, a fourth, 0, a fifth. So we see that the terms are bouncing between 0 and something positive, but that something positive is bunching up around 0 or approaching 0. So here, it looks like the set has both a max and a min, and therefore automatically has a supremum and infimum that's in the set. So 0 will be our min. That's in the set. And so also the infimum. And then there's our max. It was also in the set. And because it's a max that's in the set, it's also a supremum. So those are just a couple of examples of kind of taking a set, putting it on a number line, examining what you get, and trying to see if you can sort out the max, min, supremum, and infimum. We'll have a few of these on the problem.